In section 7.7, we'll talk about solving systems with inverses. The identity matrix I subscript n is a square matrix containing ones down the main diagonal and zeros everywhere else. For a 2 by 2, you would see the identity matrix has a diagonal of ones and zeros everywhere else. For the 3 by 3, the identity matrix has a diagonal of ones and then zeros everywhere else. Now, if A is an n by n matrix and B is an n by n matrix, such that A times B is then equal to B times A, would equal the identity matrix. Then we could say that B is equal to A inverse, the multiplicative inverse of a matrix A. Now, for example number 1, we're going to show that the identity matrix acts as a 1. So given the matrix A, we're going to show that A times the identity matrix is going to equal the identity matrix times A, which is then equal to A. So this is our matrix, which is a 2 by 2. We have 3, 4, negative 2, and 5. And so we're going to use matrix multiplication to show that the product of A and the identity is equal to the product of the identity and matrix A. So here we're going to multiply A times the identity matrix. So you have 3, 4, negative 2, and 5. And then the 2 by 2 identity matrix has diagonals of 1, zeros everywhere else. So when we multiply, we have 3 times 1 plus 4 times 0, so row 1 times column 1. And then 3 times 0 plus 4 times 1. And then negative 2 times 1 plus 5 times 0. And negative 2 times 0 plus 5 times 1. And when we find our order of operations by multiplying and then adding, well, 3 times 1 plus 4 times 0 is 3. 3 times 0, which is 0, plus 4 is 4. Negative 2 plus 5 times 0, which is 0, is negative 2. And negative 2 times 0, which is 0, plus 5 is 5. So we can see here when we do the first multiplication, we end up getting the matrix, the same matrix that we started with. And if we do the identity matrix and multiply it by A, so now we have our identity matrix and then multiplying it by matrix A. So row 1 times column 1, 1 times 3 plus 0 times negative 2, 1 times 4 plus 0 times 5, 0 times 3 plus 1 times negative 2, 0 times 4 plus 1 times 5. And if we go ahead and follow the same thing with the order of operations, we're going to end up with the same matrix. We get 3 here plus 0, which is 0. We get 4 plus 0, which is 4. 0 plus negative 2 is negative 2. And 0 plus 5 is 5.